The bleeding edge is exciting and dangerous. Adopt too early or too late, and you're likely to have an expensive system doomed to early obsolescence, a ton of technical problems, or both. However, we think that right now, the perfect mix of components have hit the market that will let enthusiasts surf that bleeding edge with maximum performance, stability, and longevity. The heart of our high-performance hot rod is Intel's X48 chipset, which is important for several reasons. First, X48 raises frontside bus speeds from yesterday's 1333 MHz to 1600 MHz. That's official speed. Like other Intel Extreme chipsets, this one lets you dig into the BIOS settings and tweak features like the frontside bus frequency, CPU multiplier, DRAM frequencies and timings, component voltages, and so on. Independent reviews show benchmarking gains of up to and over 50% when overclocking with the X48. The chip supports the latest 45nm Core 2 Quad and Extreme CPUs, DDR3 memory, and both Crossfire and Crossfire X multi-graphics technologies. These capabilities add up to a screamin' fast, very scalable foundation. But what sort of motherboard would an enthusiast want to wrap around it? Not to pick favorites, but you might take a cue from Intel's DX48 BT2. First, you need expansion slots, and this board has 5. 2 PCI and 3 PCI Express. The black slot is electrically a x4 connector, while the twin blues are x16 PCI Express 2.0 slots. Whereas PCIe 1.1 gave us 2.5 gigabits per second of bandwidth per data lane, PCI Express 2.0 doubles this to 5 gigabits per second or 10 gigabytes per second on a x16 connection, paving the way for today's hottest Crossfire cards and future SKUs capable of increasingly large and lifelike real-time graphics, the kind of data load that just won't squeeze into a 5 gigabyte per second pipe. All that graphics greatness should come with fantastic audio performance. We're still huge fans of Creative's X-Fi cards, but integrated audio now has a lot to offer if you get the right board. The DX48 BT2 uses IDT's little-known but very solid STA9274D audio codec, featuring a 95 decibel signal-to-noise ratio. That's a huge leap from the 75 decibel chips of recent years, and not far from the 100-plus decibel add-in cards of today. Intel's motherboard also carries other must-have enthusiast features, such as gigabit Ethernet, FireWire, and even 2 eSATA ports backed by their own Marvell RAID 0 or RAID 1 controller. This is in addition to the 6-channel SATA ports tied to Intel's ICH9R South Bridge. While the RAID processing from both of these chips happens in software, meaning they put their load on the CPU, the ICH9R does offer perks like Intel Matrix storage and rapid recovery technology. Keep in mind that enthusiasts like some sex appeal in their motherboards. Sweet touches here include the integrated infrared port for controlling up to 2 consumer electronics devices, an onboard power button, very handy if you're a bench testing clock tweaking geek like me, and even tombstone-shaped MOSFET heatsinks. The X48 is Intel's first chipset to use only DDR3. This marks the first time that a major player has taken a stand on DDR3 and pushed the market into the future, even while the price delta between DDR3 and DDR2 is still narrowing. Just as we saw in the transition from DDR to DDR2, the current shift must happen if memory speeds are to keep accelerating in order to meet the demands of emerging operating systems and applications. There are only 2 key factors in play here: clock speeds and latency timings. The fastest JEDEC spec available today for DDR3 is 1600 MHz, double the industry standard ceiling of 800 MHz for DDR2. You can't get too excited about clock speeds without considering timings. The 4 timing numbers you see tied to DRAM modules are the column address strobe latency, or CAS, followed by the RAS to CAS delay, RAS precharge, and ACK to precharge delay. The lower the numbers, the faster each of these timing operations completes. With DDR3 just getting its first foothold, you're seeing vendors like Crucial pushing beyond the JEDEC envelope, even if it means nudging past the standard 1.5 volt specs. The ballistic 1600 MHz modules are 1.8 volt parts with 88824 latency timings. Overclockers emphatic about furious speeds may want to try the 2000 MHz kit, running at defaults of 1.9 volts and 99928 timings. Let's circle back to making this machine into a graphics monster. One of the best graphics chips on today's market is AMD's ATI Radeon HD3870, a powerhouse that delivers best-in-class 3D speed and top-end multimedia performance. The chip owes much of its speed and lower power draw to ATI's unified shader architecture, internal ring bus memory controller design, and 55nm fab shrink. Gamers will want the GPU's quality features like DX 10.1 support and up to 24x custom filter anti-aliasing. On top of this, AMD builds in single cable HDMI output for audio and video along with its unified video decoder. Now, what if you take two of these GPUs and tie them together on one PCB? You'd have a card like Sapphire's HD3870 X2, one of the fastest video cards available anywhere, with over 1 teraflops of compute power. The two GPUs are joined by a 48-lane PCI Express 1.1 bridge chip. 16 lanes go to each GPU, and the remaining 16 lanes head out to the PCIe bus and into the motherboard's north bridge. You can double down again by planting two X2 cards on our Intel board, one into each of the graphics slots. Because the X48 supports AMD's Crossfire X drivers, all four GPUs can cooperate in tandem to deliver almost unbelievable results across up to 4 monitors. And unlike other multi-GPU technologies, Crossfire X lets you keep active windows visible on other monitors while you're running an accelerated 3D title. By picking the right parts from the right vendors, a bleeding-edge enthusiast PC can be exciting, not excruciating. Each of these components represents a higher bar in its own field, but taken together, they can elevate the end-user experience and leave buyers much better prepared for the future.